Okay, welcome to Calculus 1, and let me first go over what we've been learning in this class. And I call this the calculus triangle. And here we go. So there are two important concepts in Calc 1, and both of them are based on the idea of limit. And if you did limits back in pre-calc, great. If not, don't worry, we'll spend some time going over limits as well. From limit, we can get what we call the differentiation. And this is the study of derivatives and also the applications. And from limit, we can also get what we call the integration. And this is the study of integrals and the applications. And let's focus on differentiation first. So there's one big question that we are going to answer here, and that's the following. First, let's take a look at a graph. Let's say we have a function like this. Y equals f of x. And what we are going to do first is pick a point on the curve, let's say somewhere right here, and we are going to draw a line that tangent to the curve. So it will be something like this. As you can see, the line just gently touches the curve only one time right here. Notice that I said the line touches the curve one time, and some of you guys might be wondering, what if we extend the line right here? Wouldn't they be touching over there as well? True that, but that's not our focus. Our focus is the line touches the curve gently right there. You can imagine that you place a pencil just right there to the curve, and that's the tangent line. Alright, so now we have a tangent line, and the biggest question is, we would like to know what the slope of this tangent line is. And yeah, that's pretty much the biggest question in differentiation. And you might be wondering, why do we care about that? Well, the reason is because for slope, remember that's the rate of change. And then when we have the slope of the tangent line, this is just the slope at a point. So this right here actually represents the rate of change at that particular point. And you might now be wondering, how is it so hard to find the slope? Because we did slope back in algebra already, right? So let's take a look at the slope formula from algebra. We should remember that m for slope, that's just y2 minus y1 over x2 minus x1 from algebra. Perfect. But here's the thing. In order for us to use this formula, what do we need? We actually need 2 points. So if you take a look, suppose we have point 1, let's call this x1, y1. And then let's say this is the second point, let's call this x2, y2. Once we have these 2 points, of course we can connect the dots with a line, and then the slope will be given by this formula. Perfect. But now if you take a look at here, we have 2 points, but here we only have 1. So now the biggest question is, how can we find the slope when we only know 1 point? Right? If you haven't seen this before, you can think about it and we will make sense of it in the near future. Alright, so the good old algebra days, make sure you guys remember your algebra and all the good things from algebra and pre-calc, and check out my review videos if you need help with those things. So that's pretty much the biggest question for differentiation, and now let's focus on integration. And we also have one big question that we are trying to answer, and that's the following. And once again, I will give you guys a curve. Let's call this y is equal to f of x. This time though, we are going to start at some value, let's say a. So let's say this point, and this value. And then we are going to go somewhere else, let's say here, and we'll call this b. So now you see that we have a region, and when we have a region, it has an area, right? And we would like to know what the area of this region is. And now you might be wondering, how is it so hard to find area? Because we have done that back in geometry. True that, but let's take a look at the geometry formulas that we have seen before. So these are some of the formulas from geometry. So what do we know? Well, we should know the area of a rectangle is just length times width. So L and W to find the area is just length times width. 单deal. And we should also remember, let's say the area of a triangle. If you give me the height right here and then the base right here, then the area is what? Say it. I can hear you. Alright, I cannot hear you, but just say it. We'll put it in the comments so I can see it. Anyway, 1/2 base times height. Great. And now, maybe some of you guys will be saying circles. Okay, cool. Let's say we have a circle. I know this is not a circle, but check this out. Now we have a circle. Alright? Anyway, so let's say we know the radius of the circle. And of course, to find the area, this right here is just pi r squared. So we have these formulas from geometry. But if you guys take a look, they are all pretty good shapes. In the sense that these two shapes, they all have straight edges, right? Except for the third one for circles, but a circle is a perfect shape. I'll talk about that later. Now if you go back to here, what's so hard about this figure? Well, here we have straight line, here we have straight line, and here we have straight line. But the problem is, how about this part right here? And in fact, have you guys seen this kind of shape before? I don't think so. So of course, there's no general formula for this. And by the way, I usually tell my students that whenever I draw this, don't you guys think that it looks like a piece of bread that you guys eat for breakfast? Something like this. So let me just say, this is like a bread. A piece of toast, something like that. Anyway, if next time when you eat a piece of toast for breakfast, you can think, how do I find the area of that? And I will leave that to you guys. But let me keep it on the notes. So yeah, we don't have a formula for that. And in fact, if you go back to the circle case, you might be wondering, this right here is curvy too as well, but like we have a nice formula. True that, but I will have to ask you, how did we actually come up with pi? Why is the area of the circle pi r squared? Well, to answer that, it's actually not so easy. In fact, you can use calculus, you can use integration to answer that. And this is just the 2D version of geometry. Of course, there's also the 3D version. So for example, right here, let's talk about, of course, we can talk about a nice shape, which is a rectangular prism, or just like a box, right? And when we're talking about 3D shape, there are two things that we can talk about. The first thing is, of course, the volume. To figure out the volume for this, we need three measurements. So we have the length, width, and the height. So let me just say, usually we label this as the height, just like how tall this box is. And this is the, let's say this is the length and this is the width. So just multiply everybody together. Let me write it down better for you guys. So length times width times height. Cool. Now, how about S, which stands for the surface area? So surface area means we want to take this part. And in fact, we have this. And don't forget, we also have the back version too. So here, this part on the back, it's also H times L. We have two of them, right? So we have 2 times H times L. And then we have to talk about this side, which is width times height. So it's just 2H times W. And lastly, we have the top and bottom. So let's say the top, which is length times width, and then the bottom as well. So for that, we have 2 times length and width. And these are the formulas that we will actually be using later on as well. So good review for you guys. Good. Again, this is just a box and they all have straight edges. To measure the volume and surface areas, not so bad. But now let's take a look at the 3D version of a circle, which is a sphere, so just like a basketball. And this is how you can draw a 3D version of a sphere. So it's like this, 3D version of a circle, like that. All you care about is knowing the radius, and you can do the rest. All right, do you guys remember what's the volume for a sphere? If you do, excellent. If not, don't worry, we will review that. 4/3 pi r cube. All right. Similarly, we also have the surface area, and the surface area in this case is just like, you can think about how much material that you need in order to make a basketball. All right, so that's what the surface area is for. And the surface area for a sphere is 4 pi r squared. Wow, we have these two formulas that we actually have done back in geometry, but how come they are the way they are? Why is it for the volume we have a 4/3 right here? And how come for the surface area we have a 4? And of course, the pi is here one more time. Why? Well, don't worry, by the end of the course, we will see how to use integration to come up with the formulas for the volume and also the surface area of a sphere. So now let's go back here. And once again, I call this the calculus triangle. But here's the question. We have limit that will give us differentiation. And we also see that limit can also give us integration. But for differentiation, we are trying to find the slope of a tangent line. The slope of a line pretty much. But for integration, we are trying to find the area of a region. There are two very different concepts, right? So do you think that these and that are somehow related? It's just like this. Let's say you have two friends. The first friend, his name is, let's say, Tony. And let's say we have the second friend, let's say his name is Johnny. They are certainly two different people. You know Johnny, you know Tony, but do you think that Johnny and Tony know each other? What do you think? Anyway, if you do have friends, Johnny and Tony, you can ask them. But here is the deal. Of course, when you have two different things, sometimes they are not related. But in this case, and this is the craziest situation, in fact, differentiation and integration, they are closely related. They are related by what we call the Fundamental Theorem of Calculus, abbreviated as FTC. Of course, this is the biggest part of this class. Fundamental Theorem of Calculus actually says that if you know differentiation, you can actually get integration. Or if you want to know integration, in fact, you better know some differentiation in order to do the computation and all that stuff. So that's it. We have our calculus triangle here. And of course, for the next video, we will start by going over limits. See you then.